this line, the function using the slope-intercept form, this one using the ax by plus c. So let me just see that. So the a is 1, the b is negative 3, the c is negative 7. But this one, it's using y equals mx plus b. The b is negative 1, the m is negative 2. So let's go right here. So we have two forms here. Let me just copy.
A few minutes later.
Okay, so the first one, A, B, C form, it doesn't tell you anything directly. So you can only graph it by using the conventional method, which is the ordered pairs. You're using the table of pairs and then just graph it. But this one, this is a special one, since by presenting into this form, you can directly see what is the slope. This is the slope. And what is the y-intercept? Don't forget, it's not x-intercept, it is y-intercept. Okay, that's why the form is called slope-intercept form. Why? Because from this form, you can extract directly an information, which is the slope, and other information, the y-intercept. Okay, so from here, this equation, actually I can directly know what is the slope without using the formula of the slope. The slope is negative 2. This is the m, negative 2, the coefficient of the x. So the slope, I can directly know it is negative 2. And the y-intercept, I can directly know the y-intercept will be, it is 0, negative 1, since this is the value. So let's go to the graph. And yeah, we have calculated this green line. This equation have the gradient or the slope negative 2. And the y-intercept is 0, negative 1. So you can directly know it without seeing the graph. Just by referring to the equation, you can understand how the graph is. But this one, the first one, you cannot directly extract what is the slope, what is the y-intercept. You cannot. So how? Let me just show you this conversion. So if you have this kind of equation, this is not in the slope-intercept form, right? This is in ax plus by equals c. You need to convert into this form. You need to convert. How to convert that? You need to isolate y. So your objective is to make y isolated. So first, x minus 3y equals negative 7. So I will subtract both sides, negative x. Right? So in the end, I will have negative 3y equals negative 7 minus x. And then I will multiply this by its multiplicative inverse. So it is multiplied by negative 1/3. So it is equals negative 7 minus x multiplied by negative 1/3. So in the end, the equation becomes y equals 7 over 3 plus 1/3 x. This is still not y equals mx plus b. So the order must be the coefficient of x with the x plus the constant. So this one, let's just do the commutative for addition. So I will have, okay, so by this form, I can really know that actually the slope will be the coefficient of the x, 1/3. And the y-intercept will be this one, the constant, which is 0, 7 over 3. Or let me just put it to 1/3. It's okay? So m on the, so let's see. This red line. This red line we have calculated via the formula. The slope is 1/3. It's consistent. And then the y-intercept is 7 over 3 or 2 1/3. So this is actually, now we can feel it. So it is 0, comma 2 1/3. This is the y-intercept. About these two equations, okay? This one, it is a function. This one is not a function. So the first one is just stating about the value of x. The value of x is 3. So what is the value of y? It doesn't specifically mention that. So the second one, it specifically stated what is the value of y, which is 7. But it doesn't mention about the value of x. So you can do this approach. So when the x is constantly 3, so whenever what's value of y, so for example, if I use the table here, x and y, sorry. So the value of x will consistently 3, no matter what the value of y. That is how you translate this. So if the y is -1, it's still 3. The y is 0, it's still 3. The y is 1, it's still 3. The y is the square root of 5, it's still 3. And then when you try to plot it, this one, we have the first pair is 3, -1 here. 3, 0 here. 3, 1 here. And then when you try to plot as many pairs as you can, eventually it's just forming a lot of solutions that's showing a pattern of a vertical line. So in the end, you can conclude that this is the line, the vertical line of x equals 3. That's why it's not a function. So whenever you have statement that x equals 3, x equals 5, x equals 7, it must be a vertical line. If it is x equals 3, it means the vertical line will cross at the value of x equals 3. If x equals 5, it means the vertical line will be here, x equals 5. So how about the second one, y equals 7? So let's just use the same approach. So the value of y will be consistently 7 no matter what the value of x. So if I use the pairs here, okay, let me use different. So the y will consistently 7, 7, 7, 7. Let me just not using 7, okay, because we have a limited. So let's just use 2. Y equals 2. So it is 2, 2, 2, no matter what the value of y. So no matter what the value of x. So the x is -3, it is will be 2. -2 will be 2. 1, 2. 3, 2. Whatever value of x, it will be consistently y. Yeah, it equals 2. So let me just plot that pairs. So the first pair is -3, 2 here. The second pair is -2, 2 here. The third pair is 1, 2 here. 3, 2 here. In the end, when you diligent enough and you try any various values of x, okay, in the end it will be consistently 2 for the value of y. So in the end you can conclude that this is the line which is a horizontal line, y equals 2. So when we have y equals 2, it will be a horizontal line that will cross in the value of y equals 2. When we have y equals -1, so it will be a horizontal line in this area, and so forth.
A few minutes later.